Berardino has a very unique and special perspective of kind of a crossing boundaries, or not boundaries, but maybe working with academia and industry. So that would be a good chance to explain that.
Yeah, so one of the things is the manufacturing institutes that we do is we take public dollars and we match it with private funds, and we try to move technology forward to help manufacturing. So we don't build products, we don't sell anything, we're really trying to help enable solving problems. So I'm gonna take two extremes, one, and forgive me on one of them, it's maybe a little bit of a stretch on the cloud, operational analytics, AI, and one of them it kind of fits into it, but really high level. So one of the things we did is some of our manufacturing clients have 50, 60-year-old equipment. It's like CNC machine, or not even CNC, it's manual lathes and mills, and it's Vietnam era, sometimes World War II era equipment that they still run every day. They do a lot of manual machining, right? So one manufacturer was having a problem, they weren't getting enough output from their equipment. These are not digitized equipment, right? Well, we had launched a project on how do you go build low-cost solutions to digitize legacy equipment. Manufacturer came in, they came into our demonstration space, they saw the demo, they said, hey, I could use that. So they took $20 single board computer, tiny little Arduino, Raspberry Pi style device, $50 current clamp, because these machines take a lot of current. So less than $100, they built these little kits, they put them on, I think they had 20 machines. They put them on all their machines, they started collecting on-off data, and they sent it into their private cloud, and it was registered. Machine turns off, machine turns on, machine turns off, on, off. They ran the data through. They figured out what they thought was they were gonna have to replace all of these systems, all of these operators with CNCs and robotics and all this equipment, tens to hundreds of millions of dollars in a legacy factory. Turned out the machines never were used more than 50%. They spent less than $100 a box. They now have digitized data. They have a real-time dashboard sitting in their planning office that tells them all the information about these machines. They tied it into shifts. So now they know who's the most efficient, who's the less efficient. They're not unionized, they're not trying to get rid of people, because these are people that have been there 20, 30 years. They now know who's doing, who's good, who's bad, who needs training, help. Here's another piece. They're starting to look at, and again, this is off cheap equipment. They're starting to look at the data, and we're probably going to launch a future project in this space to start figuring out operator health. So if Mary's been running this machine and they do a lot of the same stuff, so they tie it into their planning process, they now know that Mary's working on this piece of equipment, right? She's doing finished machining on it. Well, if Mary always takes 3 minutes and 38 seconds on average to complete this, but over the last 3 months, she's been going to 3 minutes and 50 seconds, 55, 4 minutes, 4 minutes 10, something's going on. So is there an injury starting to build with Mary? Are these type of issues growing? Is Mary just getting tired and maybe it's time to move her to a different part of the factory to re-energize her? Again, think about, and I love this, the C3.ai colleague said it, figure out the problem you're trying to solve, then figure out the data you're going to collect to solve that problem. That's one example. Now I'm going to get you one that's a little more cool, high-tech and all this. I personally like this one more than the high-tech one, honestly. But the high-tech one was Dow, who's one of the sponsors here, Microsoft, who's one of the sponsors here. They're both members of MxD. They came to us with a project problem. So anybody that does planning for supply, so supply chain, raw materials, all this stuff, it's a reactive situation when something goes wrong, right? The joke that one of the people at MxD always uses, just in time's great until it's time, but nothing's here, right? So how do you change a reactive situation into proactive? So Dow has a lot of data, and they were trying to figure out by looking at models of the data, and this has been brought up, but it's like to kind of hammer it home. Models of their problem. Well, the data wasn't giving them information because they couldn't figure out why the supply chain misses were happening. They had all the information on like the path it took, where it started, where it ended, but in reality they couldn't figure out. Well, the group started looking at other data sources. So they pulled in weather data and transportation data. So they pulled Department of Transportation and they pulled weather data. And they started taking historical data. They used that as a correlation to train the machine. So now that first phase of the project completed last year, and actually tomorrow, and I can't remember which slot, but tomorrow Emily Jerger from MxD and Joel Neidig from SymbaChain are speaking on that project. They looked at that and it actually started to be a predictive tool for supply chain. Because if traffic, there's construction going on one of your supply chains and a weather hits, now you have an 80% chance that that path is going to be delayed. So the team, instead of being reactive to, we're not going to have the inventory, how do we shift our planning? now can get ahead of the curve. Maybe they pull the inventory from a different facility. Maybe they shift their planning ahead of time, so the stress and the reaction goes away. This summer, we're going to launch a follow-on project in this space to change from a predictive tool to a prescriptive tool. So for those that don't know the difference, predictive is it predicts what's going to happen. Prescriptive is why is it going to happen, and more importantly, how can I change it from happening? And so in this situation, this prescriptive part of it is the tool will actually tie into the planning and systems to try to predict, okay, here's what's happening. Now let me suggest to you how we suggest you solve this problem. So all of this boils down to data, and in the closing, I think we've all said the same thing, so I'll kind of aggregate it in my language. So you got to figure out what you want to solve. Figure out where you're going to get the data. And that might mean go collect the data, or it might mean go generate the data. You're going to aggregate it somewhere so you can actually analyze it so that you can finally act on it. And all of these boil down to that. And it can be in a very simple way. I really like my little $100 device because it's simple, it works, it makes sense, and you can take this thing a long way. Or it's more complicated with lots of AI, big machines, big data. That all boils down to the same way. So that's our perspective. We don't try to sell. I love my job because I get to play in all these different topics, and I don't really have to deliver anything. So I have the best job in the world. So thank you so much.